The fluid flow rate is the single most important factor in designing any filtration system. This parameter is so important that if got wrong has the potential to make or break your entire investment. So if you are looking to install a new filtration system and don't know where to start, please watch this video. In physics, flow rate is a volume of fluid passing through a channel in a given amount of time. The SI unit or standard unit for measuring flow rate is meter cube per second. But depending on your application or your industry, it can also be meter cube per hour or liters per minute or liters per second. Personally, we use liters per minute because it just makes things easier. We can simplify flow rate to be the tendency of any fluid to move from one place to another in a given amount of time. Now, let us understand what exactly fluid means. Let's take an example of any solid object, let's say potatoes. If we move potatoes from one place to another, they retain their shape and hence we call them as solids. While in case of water, there is no shape and hence when we move it from one place to another, there is no question of retaining its shape. On the other hand, there may be volume changes also while moving from one place to another in case of fluids, and that does not happen in case of solids. The equation for flow rate is quite simple. It is Q is equal to A multiplied by V. Now in this Q is the flow rate, A is the area of the channel or the pipe through which the fluid is flowing, and V is the velocity of the fluid in the pipe or the channel. Sometimes you don't know the flow rates or there is no way of measuring them as well. Or the flow might have so much variation in it that it is almost impossible to measure it. In these cases, it is a good idea to estimate the flow rate. Now, the design of your filtration system requires a fairly accurate number for the flow rate, but it need not be up to the point or what we are looking for while designing a filtration system is the order of magnitude of the flow rate. Now, by order of magnitude, I mean the actual flow rate is 10 and if you estimate it to be 20, that is fine. But if the actual flow rate is 10 and if you estimate it to be 100, then things will go wrong. Now, the first method of estimating your flow rate is what I call the common sense method. Now, there are two ways in which I can describe this method. The first one being you can calculate the area of the channel or the pipe through which your fluid is flowing, and you can visually estimate how much the velocity might be and just multiply them both and you will get your flow. The second method is more accurate. You can take a simple stopwatch and a bucket whose volume you know and just time the amount of time it takes to fill up that bucket and you have your flow rate. The best judge of how much flow is required can be your machine manufacturer because they know the machining requirements that you have given them. They know the fluid dynamics within their machines and hence they are better judge of estimating how much fluid should enter their machines in a given amount of time. This third way of estimating the flow rate is for machines that are already there on your shop floor or they are already running but they don't have a filtration system yet. In that case, it is quite simple. You can just list the number of pumps that are there with the machine and just add up the flow rate mentioned on the nameplate of those pumps. However, let me caution you in using this method because the flow rate mentioned on the nameplate of your pump is the ideal duty point for the pump. Now, the pumps that you have may be old and it may not follow the ideal duty point. A filtration system is basically an automated process to separate out these unwanted solid impurities from your working fluids. Now, as I explained earlier, flow rate is basically a very important parameter to consider while designing your filtration system. However, there are various factors which affect the flow rate, and you need to consider those before you install or design a filtration system. Now let's get to them one by one. Pressure and flow rate go hand in hand. They are like two peas in a pod. Now, in designing your filtration system, you need to know this relationship between pressure and flow. Pressure is basically resistance. Understanding this relationship becomes even more important while choosing pumps for your filtration system. Now, many times it is misunderstood that pump is a pressure generating device. No, pump is basically a device to overcome the resistance generated by the system. When it comes to the filtration system, where does this resistance come from? The filters in the system are basically resistance to the flow, and hence the pumps need to be designed or selected to overcome this resistance. Now, as you can understand, if this goes wrong, your pump selection will be wrong, your pipe sizing will be wrong, the surface area of filters that you would require to achieve a certain flow rate, that will be wrong. The electrical consumption is tied to your pumps, and that estimate will be wrong as well. Why viscosity plays such a big role in designing a filtration system? The short answer is, as viscosity increases, the flow rate reduces. Viscosity is nothing but resistance to flow. Now, let's take two examples. You might have these heavy machines on your shop floor. They have these lubricating oils and hydraulic oils. Have you seen or have you touched this oil? It appears to be thick, and if you pour it on a surface, it does not flow readily. That means that the viscosity is high. Now go and check the flow rates mentioned on the pumps used to pump this oil. Usually they will be in the range of, let's say, 10 to maximum 100 liters per minute. This is comparatively a low flow. The second example is the oil that you may use in actual machining operation, like grinding or honing. If you touch that oil, it is almost like water or very close in consistency to water. That means it has a lower viscosity. Now go and check the flow rates mentioned on the pumps used to pump this fluid. Those will be higher, let's say more than 100 liters per minute. I am just making these examples up. Obviously, the flow rates will depend on the application, and the pumps can be designed to suit that application, but I am talking in general terms. Piping is a very important design consideration, because with increase or decrease in pipe length, your flow rates will vary, so as increasing and decreasing your pipe diameters. Just to give you a thumb rule, if you increase the pipe length by 2 times, keeping everything else constant or the diameter constant, your flow rate at the end of the pipe will be half as much. On the other hand, if you increase the diameter of your pipe, keeping everything else constant, you will see that the flow rate has increased at the end of the pipe. Knowing the temperature of the fluid while designing the filtration system is extremely important, especially in the case of oils, because the viscosity of the oil changes with changes in the temperature. As temperature reduces, the viscosity increases. That is, the oils become thick, and vice versa. Now, as seen earlier, the viscosity affects the flow rate, and hence temperature also affects the flow rate. Other important factor is the material of construction that you would need to consider if the temperatures are high. You may not be able to use plastic pipes or anything plastic if the temperature goes beyond a certain limit, because the pipes or the equipment will certainly melt. On the other hand, if the temperature of the fluid is going beyond its freezing point of the fluid, that also needs to be considered. Now let's look at 2 scenarios as to, if you get the flow rate wrong, what effect it will have on the final system. The first one being, if we undersize or underestimate the flow rate while designing the system. It would lead to wrong pump selection. It would lead to wrong piping. It would lead to lower tank sizes for your filtration system. At the very end, what it would mean that the flow that is required for machining, or the amount of flow that should enter your machine, that is not going to be achieved. And all this you will come to know after designing and installing the filtration system. So to avoid all the confusion and avoid all the fighting later on, it is always good to spend some time right at the beginning and estimate at least the flow rate correctly. Now let's look at what happens if you overestimate the flow rate. There is not much problem, or it won't be as much a disaster compared to underestimating the flow rate, because obviously it is good to have a factor of safety in any machine design. The worst outcome that can happen if you overestimate the flow rate is the cost of the system will obviously increase. But beyond that, the working of the system won't be affected. Now, how it would impact the cost? Because you will oversize your pumps, you will overestimate the volume of fluid that you would need to store. So beyond that, I don't think there is any major issue in overestimating the flow rate. I hope after watching this video, you are better prepared to discuss with your filtration system manufacturer as to how you would want the design of your filtration system to be. In the end, I would like to wrap up by saying that a filtration system is a major capital expenditure for any company, and hence it is always better to have a good estimate of how things are going to be designed and what the final product is going to be before installing or before starting the system. I hope you enjoyed watching this video. Please stay tuned for further such videos on various topics in designing a filtration system. Thank you.